Gauge pressure can be spelled one of two ways. You can either spell it gauge like G-A-G-E or G-U-A-G-E. Either way, it's the pressure you're measuring when you use a pressure gauge typically. And so it's a measurement of pressure that is relative to local atmospheric pressure. So gauge or gauge pressure is a measurement relative to local atmospheric pressure. So it's not standard atmospheric pressure. It's whatever is the atmospheric pressure in the area that you are. So this is commonly used for compressed gases. So the times you would have used gauge pressure, and you've certainly done this in your life at this point, two things that are usually measured in gauge pressure are tires and balls. So when you're inflating a ball or you're inflating a tire, the pressure that you're actually inflating to, the pressure you're targeting, is a gauge pressure. And it's called that because that's the pressure typically measured on a gauge. So when a gauge is measuring pressure, quite often it's just measuring the pressure relative to the local ambient pressure, and that gives you, that's why it's called the gauge pressure. If you look at pressure measurements typically for tires and balls, it's most obvious with the case of the NFL pressure requirement, which became rather famous when the NFL accused Tom Brady of using an underinflated ball. So the NFL pressure requirement is that the ball must be inflated between 12.5 and 13.5 psi. So pounds per square inch. That's a English unit pressure measurement. It's commonly used in the US as well. So pounds per square inch there. NFL, interestingly, does not specify a temperature for that, which of course is just flat stupid. And that's how the whole problem happened with the Brady thing. The ball was very cold that day. And in fact, the pressure that was measured was exactly what you would predict if you had used the ideal gas law to predict the ball temperature on that particular day. But that's neither here nor there at this point. But if this were an absolute pressure measurement, of course, the atmospheric pressure is typically around 14 psi. That's standard atmospheric pressure most days. And so if this were an absolute pressure measurement, obviously the atmospheric pressure would be greater than the pressure inside the ball, and the ball would be crushed completely flat. That's not, of course, what it is. It's a gauge pressure measurement. So this is the NFL requires that the ball be pressurized to 12.5 to 13.5 psi above the local atmospheric conditions. So the actual mathematical formula for gauge pressure, very simple, of course. It's the absolute pressure minus the local atmospheric pressure. And it is important to remember that this is local, and you can remember that because I say you can think of just holding a gauge, and that gauge is going to be able to sense the exterior pressure around it, and it's going to measure the pressure of whatever you're measuring relative to that. This atmospheric pressure can change, so if the atmospheric pressure changes, if PATM changes, then P gauge changes. So you can have something, for instance, a ball, and if you move it to a different atmospheric condition, then its internal gauge pressure will change. So, of course, its absolute pressure, that won't necessarily change. All right, so that's gauge pressure. Vacuum pressure is, gauge pressure is only used for P greater than P atmospheric. So you never use a negative gauge pressure. You always have gauge pressure is always positive. P gauge is always positive. Gauge pressure is always positive. You only use it when it's positive. If you have a negative gauge pressure, or would have a negative gauge pressure, then you switch to vacuum pressure. So vacuum pressure is the opposite. Vacuum pressure also measures pressure relative to the atmosphere, but that's for cases where P is less than the atmospheric pressure. And so the definition of vacuum pressure, P vacuum is equal to the atmospheric pressure minus P. So once again, P vacuum will always be positive, always positive. If you have a negative vacuum pressure, you should switch to gauge pressure. So P vacuum is always positive. If you imagine a situation where P atmospheric is equal to 101,000 newtons per meter squared, that is kind of standard atmospheric pressure, then a perfect vacuum would be P vacuum equals 101,000 newtons per meter squared. So you have a positive vacuum pressure. This would represent a perfect vacuum. That is a situation in where up here this P is just 0, so your P vacuum would just equal exactly what your atmospheric pressure is. So that's how you use vacuum pressure. Gauge and vacuum pressure can be useful, particularly when you're calculating forces on objects. Often when you're calculating forces on objects, actually as you did in last class, the atmosphere kind of cancels itself out. So vacuum pressure and gauge pressure are sometimes mathematically useful for calculating pressures, quickly, forces quickly, because they automatically, essentially the atmospheric pressure has already been removed from the equation. But you have to be very careful, of course. Gauge and vacuum pressures are not absolute pressures. They cannot be used in the ideal gas law, and they do not, represent, of course, the true pressure in the system. So you have to be very careful when you're using them, and be very aware when you see pressure measurements to make sure you know whether they really are gauge pressure, vacuum pressure, or what we hope people will be using mostly, absolute pressure.